Good morning to one and all present here. Myself, R.Ashokkumar, Assistant Professor, Department of Safety and Fire Engineering, KSR College of Engineering. Today our topic is strength of materials. The overview of the strength of material is, in Unit 1, it contains stresses, strain in deformation of solids. In Unit 2, it contains beams, types of loads, and various types of stresses involved in the beams. In Unit 3, deflection of beams. In Unit 4, it contains torsion. It contains solid shaft, hollow shaft, and open coil springs, closed coil helical springs, and its types. In Unit 5, analysis of stresses in two dimensions. It having thin cylinder, spherical cylinders, and maximum shear stresses, principal stresses, and principal planes. The objective of the course is, this course objective mainly focuses on teaching students to analyze how the materials and structures deform and fail under various loads. It understands the concepts like stresses, strain, shear, bending, and torsion, and it applies these principles to design a safe design and efficient structural components like beams, columns, and shafts. It will ensuring they will understand the real world forces. Its key goals include evaluating the internal forces, understanding failure theories, and analysis behaviors under complex loadings, it forming the basis for core mechanical and civil engineering designs. Industrial applications of strength of materials. It is a vital in across all industries like civil, mechanical, and aerospace for designing safe and durable structures for its components. In mechanical industries, it is useful to design a shaft, gears, springs, bolts, and bearings, etc. And also we find the stresses and torsional analysis of power transmission in shafts, failure analysis, and fatigue strengths, that things also be analyzed. In civil engineering and construction applications, uh, design of beams, columns, slabs, bridges, and buildings. It is also used to calculate the bending stresses, shear stresses, and deflections involved in the beams. And it is very useful to select the materials based on the load carrying capacity. In automotive industries, it is useful to design the chassis of chassis, axials, suspension springs, shafts, and also it is very useful to analyze the impact loads and fatigue stresses produced in the automotive industries. These are all some examples for industrial applications for safety students. Fire resistant design of buildings, design and safety of firefighting equipments, industrial safety and accident prevention applications. These are also fundamentals of strength of materials. Rigid body. A rigid body is defined as a body on which the distance between the 2 points never changes whatever to be force applied on it. That is known as rigid body. In deformable body, it is defined as a body on which the distance between 2 points changes under action of some forces when applied on it. It is known as deformable body. Stress. Stress is nothing but a external force to the area. There are different types of stresses are used in strength of materials. First one is normal stress. The stress or force acts perpendicular to the surface. Then next one, tensile stress. It is pulling force that elongates the material, that is known as tensile stress. Then next one, compressive stress. Pushing force, it will shortens the material length, that is known as compressive stress. Then shear stress, two equal and opposite forces acts tangentially on a plane, that will get the shear stress. Then next one is strain. Strain is nothing but an external force. There is some change in dimension of the body. Strain is equal to the ratio of change in length to the original length. There are different types of strains are there. Tensile strain and compressive strain and shear strain and finally volumetric strain. The next one is beam. Beam is nothing but a structural member which is supported along the entire length and subjected to an external force or load acting perpendicular to the center line. It is known as beam. In beam, there are various types of beams we are using. Uh, and first one, cantilever beam. Second one, simply supported beam. Third one, overhanging beam. Fourth one, fixed beam. And fifth one, continuous beam. Cantilever beam is nothing but a beam with one end free and other end is fixed, is known as cantilever beam. There are few examples I will paste it here. The next one, simply supported beam. In simply supported beam, beam supported or resting freely on the supports at its both ends. That is known as simply supported beam. Then next one, overhanging beam. If the one or both the end portions are extended beyond the support, it is known as overhanging beam. Then fourth one, fixed beam. This beam whose both ends are fixed are built into the walls. Both ends of the beams will be fixed. That is known as fixed beam. Then fifth one, continuous beam. A beam which has more than two supports. That type of beam is known as continuous beams. The next one, there are different types of loads are used in strength of material. There are three different types of loads we are using. Then first one is point load or concentrator load. The load applied on a particular point or a single point or a small area. That type of load is known as point load or concentrator load. The next one is uniformly distributed load. The load will spread from starting to ending over the total length, is known as UDL or uniformly distributed load. The next one, uniformly varying load. The load can changes linearly from starting to ending. That type of load is known as uniformly varying load. Thank you.